All right, so in this video, we are going to talk about the empirical rule, okay? All right, so let's get started. All right, up here I've just got a picture for reference of our percentages of the empirical rule, so I'm going to refer back to that picture. Here's our first example. So it says the distribution of weights of newborn babies is bell-shaped with a mean of 3,000 grams and a standard deviation of 550. Okay, so what I would recommend doing when you get this information is to go ahead and draw out the bell curve. All right, in the very middle, we're going to put the mean. Okay, we're going to add one standard deviation at a time as we move to the right. So this will be 3,500. And then if I add another 500, that'll be 4,000. And then if I add another one, that'll be 4,500. All right. And then as I move to the left, I'm going to subtract 500 each time I go. All right. So there's my bell curve with my mean and standard deviations. All right. So question A says, what percentage of newborn babies weigh between 2,000 and 4,000 grams? So what I'm going to do is I'm going to look on my picture and I'm going to find 2,000 and 4,000 grams. And I'm going to count how many standard deviations away from the mean they are. So 1, 2, 1, 2. So we are 2 standard deviations away from the mean. So that means my answer would be 95%. Okay. For question B, what percentage of newborn babies weigh less than 3,500? So now I'm going to go right here. And I want to find all this area to the curve to the left of 3,500 because of this word right here, less. Okay. Well, that is 1 standard deviation away from the mean. Okay. So I need everything here and over. All right. Well, I know this part is 50% of the data, okay? And this part right here is half of 68, which is 34%. So I'm going to take 50 and I'm going to add 34, and my final answer will be 84%, okay? All right, for question C, calculate the range of birth weights that would contain the middle 68% of newborn babies. So that middle 68% will be 1 standard deviation away in each direction. All right, so if I find my mean, which was right here, I need to go 1 away in each direction. So that'll be from 2,500 to 3,500. Okay, so there's our first question with the empirical rule. All right, so let's make some room here. All right, let's see here. 27. Suppose the starting salaries for graduates of one university have a bell-shaped distribution with a mean of 25,400. Oops, an extra 0 there. And a standard deviation of 1,300. Approximately what percentage of graduates have starting salaries between 22,800 and 28,000? All right, so we're going to take this mean and we're going to add that standard deviation. And then we're going to add it again. And I'm going to stop right there because that's one of the numbers in my problem. All right, and then I'm going to also subtract it. And then I'm going to subtract it again. And I'm going to stop right there because that's the other number in this problem. All right, so these 2 standard deviations, or these 2 numbers, are 1, 2 standard deviations away in each direction. So I know that'll be the middle 95% of my data. Okay. All right. 28. Ooh, change that. Okay. So suppose the electric bills for the month of May in one city have a bell-shaped distribution with a mean of 119. And a standard deviation of 22, what percentage of electric bills are greater than $97? Since 97 is less than 119, I'm going to take 119 and I'm going to subtract 22, and I actually get 97. Now, I want to find the area greater than 97. So I'm going to find this part of the curve, okay? Well, I know from 119 over, here's 50% of my data, and then this chunk right here is going to be another 34% of the data, because that middle part should be 68% total. So my answer to this will be 50 plus 34, 84%. Okay. All right. 29. All right. Again, we have a mean of 119. Standard deviation is still 22. Now we want to know the percentage of bills that are less than 163. So I'm going to add 22. And then I'm going to add 22 again. And I'm going to stop right there. All right, now I want to know less than that number. So that's the area to the left. All right, well, I know here's 50%. This chunk is 34%. This chunk is 13.5%. So I'm going to add these three numbers together. And my answer is 97.5%. All right, so that should help us with the empirical rule. All right, now let's look and see what we have for Chebyshev theorem. Okay. All right, now this guy sounds tougher than it actually is. Okay. First of all, our theorem states, let's see, 1 minus 1 over k squared. So if k is 2, we're going to do 1 over 1 minus 2 squared. That's 1 minus 1/4. That's 3/4. All right, written as a decimal, 0.75, written as a percentage, 75%. Okay, if k is 3, that'll be 1 over 1 minus 3 squared. That's 1 minus 1/9, which is 8/9. All right, that decimal is 0.8888, on and on and on. So we can say 88.9%. Okay, so all of our answers for these Chebyshev problems are either going to be 75 or 88.9. Okay, one of the two. All right, so let's read this problem. So here we go. It says, suppose that salaries for associate math professors at one university have a mean of 64,900 and a standard deviation of this. What is the minimum percentage of associate professors with salaries between these two numbers right here? All right, here's what I would recommend. Take the bigger number, okay? Subtract the mean. Okay. All right, so we should get, when we subtract that. All right, now divide by the standard deviation. All right. and we'll get 2. That is your value for K. All right, so again, to recap, I took the bigger number and I subtracted the mean. Then I divided by the standard deviation. That's my K. If K is 2, my answer is 75%. All right, so let's try it again with another example. All right, here we have a mean of $230, standard deviation of 58. What is the minimum percentage of electric bills between 56 and 404? All right, so we're going to take the larger number and we're going to subtract the mean. Okay, so let's see here. Then we're going to divide by our standard deviation, and we should get 3 there. So that's K. So if K is 3, my answer is 88.9. Okay. All right, and that's it for empirical rule and Chebyshev theorem.